architect Anna Cyriac to start this session with a prayer song.
महितमां शक्तिदन दानमेन्नेगी മനതാരിലെങ്ങും വിളങ്ങട്ടെ ശുദ്ധി ചിരമായി വളരട്ടെ ഞങ്ങളിൽ ഭക്തി സേവനം ഞങ്ങൾക്കു ധർമ്മമാകണം സേവനം ഞങ്ങൾക്കു കർമ്മമാകണം മാതൃഭൂവിൽ തന്നെ ജീവിതം പോക്കാൻ ജീവദാതാ നീ അനുഗ്രഹമേകൂ ജീവദാതാ നീ അനുഗ്രഹമേകൂ.
Okay. Let me take this opportunity to introduce myself. My name is Megha Mibu and I am a CEE volunteer. I have a bachelor's degree in architecture from Manipal School of Architecture and Planning. I was working in Kochi in a Kochi-based firm called Jibu and Thomas Architects, and currently I'm working as a freelancer. Today, as you all know, is 14th of December, and it is celebrated as the National Energy Conservation Day every year subsequent to the Energy Conservation Act of 2021. The theme declared by the Bureau of Energy Efficiency this year is Conserve Energy and Save Future. We have all gathered here today to be a part of this knowledge sharing session conducted by our host, Dr. Mathew, founder Trustee. She is a civil engineer, urban and regional planner, social scientist, having done her PhD in sustainable cities. Due to her social commitment, she has formed this public trust Center for Environmental Efficiency and is now tirelessly working to reach her goals. I would also like to introduce CEE Trustee Anthony Katikaran, also her spouse, who is unconditionally supporting her for this global cause. He is a mechanical engineer and a certified energy author. CEE is a public trust dedicated to the rightful environment management. Dr. Mathew believes that the two strong indicators of sustainability is environmental efficiency and carrying capacity, introduced through her PhD dissertation, have applications from global level to individual level. The application of these theories will facilitate an improved and more efficient living environment and make the world a better place to live in for future generations also. The main topic of the webinar is Green Buildings for Environmental Efficiency, which is directly connected to the declared theme. Without further ado, I would now like to invite our founder trustee, Dr. Mathew, to speak more about how this topic is related to the theory of environmental efficiency.
Thank you, Architect Megha Mibu. I'm so happy to hear few words, people like you, that youngsters, because for you only I'm doing this, or we both of us are doing this to make awareness about the environmental efficiency and carry capacity, which are two strong indicators of sustainability and which are often like two sides of a coin. So one is achieved, other one will automatically be achieved. And environmental efficiency refers to the urban centers, while carrying capacity refers to supporting regions or ecosystems. And these two indicators which have been formed, it is based on three global indicators formed by world famous agencies such as UNDP and Global Footprint Network, that is HDI, EFP and BC. HDI has been formed by Human Development, that is UNDP, and EFP, Ecological Footprint and Biocapacity, have been formed by Global Footprint Network. And based on which I have made, this is actually the environmental efficiency and carrying capacity theories are a trade-off between these three items, that is HDI, EFP and BC. And the environmental efficiency has been carried out by an approach known as output by input, while carrying capacity is formulated based on capacity by consumption approach. And now all of us know that today is World National Energy Conservation Day, And I would like to mention about our Sustainable Development Goal 7, that is affordable and clean energy, which has been declared by nations. So based on an agreement in Paris in 2015. So this theme is related to SDG 7 at the global level, and at the national level, they have formed in 2002 this National Environment and Energy Efficiency Act. And this Bureau of Energy Efficiency is only conducting, they are also making this day, that is National Green Building Day. National Energy Efficiency National Energy Efficiency Day, that Energy Conservation Day. And so this is the thing. And today Ashiqua is going to, in order to hear more detailed explanation about green buildings and energy efficiency, it is better to concentrate on Ashiqua, architect Ashiqua. He has specialized in green buildings and energy efficiency. But even I want to learn from her, because conceptual level of information only I have, and I am interested to know further about it, to know about it. But I would like to say a few words, like when I formulated this environmental efficiency theory, I have found two things which are coinciding with environmental efficiency theory that is happening in this in India. One is this green buildings, and the other one is CRZ rules, coastal regulation. So I will tell you, green buildings, what is happening is human development is protected and encouraged, while ecological footprint is reduced through renewable energy and energy conservation measures. So human development is protected. That is the basic thing, because unless and until human development is protected, no efforts of environmental management will be a success. Similarly, CRZ regulation also, what I have found is human development is protected, because there is very less stricter rules are there for the urban centers like municipalities and corporations, but for panchayats, the rules are more strict, because panchayat or region belongs to the ecosystems, while the cities belongs to people. So these two things only I found that it's coinciding with the environmental efficiency theory, and all others are sometimes against environmental efficiency theory, what is going on in our country. So I am making my effort to create awareness to people that this is the way it should be done, and we should be a bit be long-sighted to achieve rightful environmental management. Now, I think that is the thing. That's what I want to convey to you, being an introductory speech. And now I am just giving Ashiqua. So I invite Ashiqua Sulthana, architect Ashiqua Sulthana, to deliver her presentation. Thank you.
Thank you, ma'am. Good evening, everyone. I hope I'm audible to all.
Yes, you are audible to me.
Yes. So before starting the presentation, I am sharing my screen. I think I'm able to. So I am really excited to be a part of this program, because I see this platform as something to educate more people and inspire more people to hold the way of green buildings. And actually, you can consider the session as an introductory one, because this will throw you insights about the field, and you may start your further research and further reading today, and from the information that you are getting from my presentation. So first of all, let's discuss why do we need green buildings? A green building is a buzzword. We know it's everywhere. Now we can say that green buildings are going to get incentives from different governments, or green building is getting promoted by UN, or any other platform that is being discussed about climate change or the sustainable development goals. So what is green building? Okay, the most important thing green building is responding is about the climate and about the natural environment. The green buildings can not only reduce or eliminate the negative impacts to the environment, but also it can cause some positive impacts. Like, it can generate, compared to the impacts, negative impacts that it can cause, when we compare to a conventional building, it generates its own positive environment, its own occupant comfort, its own resource efficiency, its own empowerment to the biodiversity and everything. So we can say green buildings are not just for the present. It also consider the pillars of sustainability to meet the needs of the present, along with, without disrupting the ability of the future generations to meet their own needs. So it can either be to the humankind, or towards all species, and also to the all the species on the earth, and all the species on the water, plus towards the entire species on the greenery. We spoke about the sustainable development goals and the global agenda. So how do we achieve the sustainable development goals? In the opening speech, Megha was explaining clearly about her thoughts. So when we think about what all SDGs are clearly meant to the green, ecosystems, or the green building especially, let's talk about the goal number 11, goal number 7, and goal number 9. So all these strategies, what we are going to formulate, can only be achieved through transformative changes. It should not just be in the infrastructure, but it should be definitely considering the economic, the social, and the technological factors. And the current negative trends in biodiversity and ecosystems will undermine this progress. So we have to think about how can we, overcome the larger goals, the poverty, hunger, health, water, or whatever is related, along with the efficiency ones, like what we are going to build along with the efficiency paradigm. Like we may say the resource efficiency. What all resources are we consuming? We are consuming energy, we are consuming water, we are consuming food, okay, and we are consuming almost everything on this earth. So the efficiency paradigm adds a certain level of this responsibility for whoever is using it, especially the human beings. So act of global warming, okay, and why this building, the sector is impacting, and what is the share of it, I'm going to discuss in the next slides. So we know that the temperature change in last 50 years, and the rise of 1 to 2.5 degrees Celsius is posing to it's so dominant nowadays, and how it is going. And we can also see that the UNEP has recognized the building sector has the largest potential for significantly reducing the greenhouse gas emissions compared to other major emitting sectors. We know the major emitting sectors will be the industries, right? So after industries, it can be the transportation sector. So when we think about the productivity and the growth of on other sectors, the impact that we can create by conserving resources in the building sector towards reducing the greenhouse gas emission will be will be the least task. Okay, and when we think about the the global agenda of 2050, so it is also found by the UNEP that the building sector has the potential to make energy savings of 50% by 2050, and this will support limiting global temperature about 2 degrees Celsius. And if we look into India, our country, we know the 7th largest country in the world, but our ecological footprint, our building footprint is having drastic growth. And this rapid growth is kind of unplanned in many places. And this impact about 62% of the carbon dioxide emissions in energy production sector in India. And we know energy production is one of the most carbon dioxide emitting, the process compared to the industry or the agriculture or any waste or any other fields. And if we look as we connect with the the building footprint and the energy demand, let's simply see the industries consume more in India. It's about 42%. Then comes the building, it is 33%. And as I said, let's keep industry apart and let's talk about the building sector, because today I will be speaking with emphasis to energy efficiency, because today is National Energy Conservation Day, all of us know that. And energy conservation is the most environmental pillar in terms of green buildings. If we look into any kind of evaluation systems, green building evaluation system that we are coming towards the end of our presentation. And let's see, when we take the building, this 33% of the buildings, the residential buildings consumes almost 25% of the total energy consumption. And this commercial means the shops 9%, and other sector will be 67%. And it is also forecasted by Bureau of Energy Efficiency that by 2030, our building stock in million square kilometers shall be more than 900 or 1000 maybe. And also this kind of the consumption, like the type of building typology that is going to come up in future will be most like offices, education, retail, hotels, and hospitals. But the COVID scenario may change this kind of forecasting, because this has been done before COVID. So they have found that the offices will be the most developing the building typology, and then comes to education and retail. But this can be a little altered, but still the energy consumption which is happening in building is not going to change, because the building footprint is not going to change, and the population is also not going to change. And if you look into our country again, this is a statistic which shows the electricity consumption in building in gigawatt hour. So here also we can see the building shows the most growth compared to agriculture and other industry. This is the potential energy forecast that we can say, which is having a saving potential. And let's look close into the ways of building energy consumption. We were generally saying, okay, energy is getting consumed in building, but how are we consuming buildings? How are we consuming energy in buildings? First one, let's see about residential building. We know in any building, thermal comfort is the #1 factor everybody has to maintain. So in residential sector, we use more fans in India than air conditioners, and lighting comes next, and refrigeration and TV, everything other comes in as the least. So, and let's come to the commercial building sector. In commercial, lighting consumes more, HVAC is, and all other constitutes only 8%. So the motto of green building is resource efficiency. I already spoke to you. The resource is not just energy. Let's see what all resources can be saved. Energy is the first and foremost thing, and the most efficient way that we can save. Water is another resources, and land, because the building is being built on this earth. And we know how the lands are getting altered just for occupying cities, towns, and other infrastructure along with the buildings. The materials. Material means especially the construction materials and the manpower that we are going to use, the technology that we are going to use. So the resource efficiency throughout the life cycle of the building can be applicable in all these 6 sectors. And we have to see how efficient we can make it, how we can do that. Let's start from the planning. Okay, in the planning perspective, we know that a systematic and efficient way of planning is needed from the starting itself. Let's think about an integrated approach rather than a linear one, which starts from architect, then goes to structural engineer, then goes to the MEP engineer, and then goes to the contractor, or at last it goes to the PMC. That's how it happening here nowadays. So how should it be? We have to clearly demarcate the design phase, the building phase, and the operation phase, and we may have to, fill the loop through the circular mechanism. So it can be starting from the design stage. The architect will be defining the conceptual design stage, and then comes to the detailed design stage. Then there can be the analysis. It can happen using the skills of the MEP engineers, maybe electrical or maybe HVAC. And then there will be a set of documentations happening, and the fabrication on site happens, and we may have to study about the, the payback period that of what we are going to invest, and or the energy consumption or the water consumption, or the entire looks of the building. So everything pays off. And finally, we can take the help of the technology, and let's come to the integrated approach, which brings together all specialists. It can be starting from the decision making of the client, and then assigning an architect, structural engineer, interior designer, landscape designer, MEP engineer, and construction contractor. Everybody should be in the single umbrella, and everybody should think about the circular loop that we are creating in the first. Because in our economy, like, which is promoted by the green buildings, if it's an advanced one, it should be based on the circular principles. So let's come to the strategies, the factors that affect the design of a green building. First and foremost, we know that where are we going to build? So the location matters a lot. So once we fix the location, the first thing we should analyze should be the climate. So climate is a large term. We know that it's the weather conditions, the characteristics of that location for a long period of time. And it's purely for a large area in general. And there comes the importance of the microclimate. Okay, we know in the coastal belt of India is considered in warm and humid climate zone. So do you think that almost all coastal lines falls under this factor? What if there is a hillock, or what if there is a some kind of streams or some kind of pond, or because all these factors affect the microclimate of that particular region. So first of all, let's clearly map the temperature and humidity on a large scale, the major climate factors and the microclimate factor. Then comes the solar radiation, then the wind speed and the direction of the wind, then the landforms, the vegetation, water bodies, open spaces, and how are the surrounding features of your site works. So that shall be the first thing has to follow. And here we can clearly analyze all these factors with the help of various scientific tools, various climatic tools. So I just kept some examples of a sun path diagram and to analyze the radiation, solar radiation and the solar direction, and also wind rose diagram to understand the wind speed and wind direction and other climatic charts. So we can clearly analyze. So based on this, the first intention of us to keep, because whatever assumptions I am going to say throughout the session will be based on the warm and humid climate, okay? Unless and until we fix that, we may not be able to explore more strategies. And maybe in the future session or in the Q&A session, we can discuss more on if you have any other queries as well. But assume that we are discussing about the warm and humid climate. So first of all, we should start with mapping of the overheated period. So suppose our site is here. You can see a vacant plot on our screen, and there are surrounding features that we are mapping. Whatever trees are there or surrounding buildings are there, then we have to analyze the solar path. So based on that, we can understand which facade gets more heated, east or west or north or south. And due to the presence of the local factors or presence of the microclimatic factor, what are advantages that we can take? So we should go for a three-tiered approach. The first one should be the heat avoidance. And the second one should be the heat avoidance, and then comes to the passive cooling. If your strategies are not able, you may not be able to avoid completely, you may go for passive cooling first. And then you may go for the mechanical one. So mechanical option is the least bothered considering the principles of, green buildings. And let's come to the strategies. So initially I was broadly saying the principles, and if we list out the strategies, we may have to work out on the window glazing. We may have to work out on some kind of roof options. We may have to work out on thermal insulation. We may have to work out on the shading devices and also the internal, external insulation. So all these factors are there. So what are the underlying principles behind taking decision on each steps? So the building physics. We know about physics that we are learning from the school stages, right? And we know the ways of heat transfer happens in any related to any thermodynamic system, not just buildings. Okay, the conduction, convection, and radiation. We know the conduction happens through the contact, and the convection happens through the heat transfer happens through a medium of air. And in radiation, the heat gain happens through direct, transparent, or translucent, whatever medium is there. And in the coming slide, let's see. So if we connect this with our building, the conduction happens through our walls, roof, floors, and windows. Convection happens through inside and outside through the opened windows or any cracks or leakage or whatever. And let's come to the radiation. Mostly happens through the windows, skylights. So we spoke that we have to maintain this thermodynamic system. For that, we have to assess the envelope of our building. So this is the first step. So what is an envelope? Envelope constitute the parts of building which is exposed to the external environment. Okay, it can be the walls, it can be the roof, and also it can be the floor, because floor is not exposed to another building. Floor is exposed to the earth. Earth is an environment, right? So as we wrap a bowl with a paper, we can think that in our mind. We can wrap our building using an envelope. And when we think about this envelope, we have to make it air controlled. We have to make it vapor controlled. We have to make it heat controlled. And as a climate like Kerala, we have to make it rain controlled for sure. So these much of strategies has to be there in your mind. So, and when we think about this envelope system, do you know a few facts? So what do you think is the element that takes more heat? We know the wall transmits heat, transfers heat from outside, right? But most of the heat gain happens through walls. That's true. And but when we think about the component of, the ratio of window to wall, window is only a small contribution. Like in general, if you look in Kerala, we generally see buildings which is having window to wall ratio between 15 to 25 or mostly 35. So even in that kind of buildings, we will get about 25% of heat gain through doors and windows. But if you're suppose your building envelope, building wall, maybe another substitute maybe of 60%, but that 60 or 70% of wall conducts only 35%. And through roof, it will be again 25%. Through floors, it is 15%. So this is how the previous researchers show. So if we make a tight system, like tight thermodynamic system, which is controlled and which is opening up whenever we need it, then we will definitely able to tackle this heat gain or heat loss. So what are the major indicators that we have to think when we design an envelope. First one is the walls, the opaque construction we say. Second one is the roof. I said cool roof because cool roof is a concept that we use material that is of high emittance and high reflectance, so that your heat will reflect back, and you will only have a less amount of heat transfer compared to the conventional roof. And fenestration should be the third indicator. And fourth indicator is the infiltration. Infiltration can happen through any component, like it can be through the small cracks between the fixing of the window and the wall, or it can be through the cracks on the wall, or it can be through the ventilators that we generally give. So all this infiltration is the fourth indicator. And finally, the indicator that we have to keep in mind is the daylighting. Okay, we are doing everything for heat gain, to reduce heat gain, but we are not supposed to compromise the daylighting. So there should be, we have to connect our designs with the underlying science. So we have to translate all these challenges, and we have to formulate the solutions based on the scientific backup. We know that in Kerala, we generally say, okay, the bedroom should face this west end, so that in east, this, what do you say, the solar radiation will be more in the morning. And so those kind of assumptions, let's leave those assumptions and let's think about the climate chart, and let's understand how the solar angles are hitting your site, and how your surrounding building is casting shadow on your plot, and it may have how will it affect the heat transfer towards your wall in your building in future. Okay, similar to that, let's go beyond. And I found this paper. If anybody want, you can note down, because in this particular paper they have listed out almost everything. What are the key factors you have to look when you design this particular thing? It's by Geo and Heo Kalsi. Okay. And optimize the form of building envelope. The first one is, I'm going to explain whatever was there in the earlier slide, but just showed you that summary. So first one is, we have to optimize the shape, or you have to do the massing, or based on the orientation, right? So here you can see with the same FAR, you can see 3 building forms. And what do you think will be more efficient in terms of heat transfer? The first one, second one, or third one? The first one is having more wall area, right? And more roof area. So definitely the heat transfer will be more. The second one is also having same amount of, the wall area is more and roof area is little less, but still it's exposed. In the third image, you can see with the same FAR, but using a different design option, it gives mutual shading through the jet outs and the projections. So similar to this, we can work out on the shape. That's the first thing. The second one, we can limit the window to wall ratio. How do we limit that? So in the first image, you can see window is only 20% of the wall. The second image, windows somewhat 40% of the wall. And third image, windows about 80% of the wall. So how is it going to impact your design? Indeed, we need lighting, but do we need an overlit space? We don't need, right? We don't need an underlit space. Similar to that, we don't need an overlit space. So we have to keep the lighting to optimum. For that, we need shading devices. So the shading devices can be of the contemporary pattern, or it can be of the, the traditional pattern. And the windows shouldn't always be in rectangular shape. windows shouldn't always be in somewhere like, this 3 feet above, and window will have some 5 feet, and there will be lintel above that. So we don't have to follow the conventional practice. What we have to look to be the amount of daylight that is getting on our work plane and the amount of heat ingress that we can reduce. So here you can see that how this window wall ratio is adding this impact to your cooling load. The first graph is for the south facade. This south facade, the window wall ratio is being increased from 30% to 90%. So we know south is a facade which is having more solar radiation, right? East and west also has, but the intensity is more. But when we consider the duration, especially if you consider a daytime operating building, then east and west facade will be having somewhat, starting from 8 o'clock to 10 o'clock. We may not have to consider that incident radiation. But on the southern facade, throughout the working period, like in the afternoon in the east facade, there will not be any direct solar incidents. But unlike the case of southern facade, just see the impact of cooling load. The cooling load also considerably increasing as we increase the window to wall ratio. And let's see the sum up of all facade, like east, west, south, and north together. Then we can highly understand how these window wall ratio is 30 to 90% is adding cooling load to the double, right? So let's look into the factors that we can make our envelope efficient. So when you think about the opaque constructions or the cold roof, the factors we have to think, the energy efficient material or the material that we help us in reducing cooling load will have better U value, better R value, better reflectivity and emissivity. What are they? Let's come to that. And when we consider to fenestration, better U value, better SHBC and better VLT, infiltration, envelope sealing and daylighting, useful daylight illuminance. Okay, these are the indicators. Okay, R value or thermal resistance. This is also, let's go back to some physics classes. We know what is resistance. Okay, resistance is the hindrance to flow of heat. If your material is having resistance to something, means it will definitely reduce the amount of heat transfer to a window. And this conductance is the reciprocal of the resistance. Okay, so the conductance of your material should be low and the resistance of your material should be high. And what is the U factor? U factor is the overall heat transfer coefficient, which is the fraction of the R values, the resistances of all these materials. So when do you think the U value is important? Because R value, when we talk about R value, it's just for a single material, right? But when we think about wall or roof, it is a series of assembly. They're actually only, we are not using only a single material. There will be a series of assembly, like the plaster will be there outside, and above that there will be a coating, and there will be outer plaster, there will be a brick wall, and there will be inside plaster, there will be a layer on the inside, like finishing layer, painting maybe. All these factors will be there. And apart from that, there will also be the impact of the air. Like, you must have heard of soil air temperature, because the air is getting heated. The immediate air that is above, that is clearly touching the surface of the exterior wall, is also getting heated. So that outside air film will also add some kind of heat towards your wall assembly material. So considering all these factors, in general, building physics has this attribute named U value. And U value will be measured in watt per meter square Kelvin. So it is the overall heat transfer coefficient. So if you're having a higher U value, means the heat transfer will be more, right? Because your resistance will be less. U value equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, U equal to 1 by R. So I wanted to show you this image because you can see, please understand this, keep in your mind. If your U value is high, your arrows is high, the heat transfer will happen easily. And if you having, some lean arrows and you are going to break the wall, then it may not break that easily. So the heat transfer will be a little less. So this is how, okay, I already explained about the conductivity. Okay. So similar to this, there is a property for glass when we select glass. Because when we talk about energy efficient material, or when we talk about, the materials that are perfect in reducing cooling load, we cannot simply say single material. Rather than we can say the principle of how we can create the assembly of that particular materials. Let's come back to the this glass. The glass has also the property of conductance, and it also transmit light. Because we know the sunlight has two components, right? The first component will be the heat component. No, the first component will be the light component, because we are, visually, we are experiencing only the light component. And the second one is the heat component. So when we select the glass, we have to think about both these components. We have to allow the light component to the maximum to the indoor. At the same time, we have to limit the heat component. So for that, U value is there, but still when it comes to the glass, there is another factor named solar heat gain coefficient. Because U value is the direct transmitted through contact. You know how it works. And SGC works in the case of light. It is the fraction of light that is passing through the window, and the fraction of light which is distracting. So if you say your SGC, this will be a value between 1 to 100. So we generally write from 0 to 1 in like fractions. So if you say your SGC is 0.33, then 33% of the solar heat will be coming inside your window through your glass. And another, this 67, right? 67% will be hindered. When it comes to the VLT or VT, VT means visual transmittance, or VLT means visual light transmittance. Also, sometimes we express. So VLT also works similar. What is the fraction of light that comes inside? If 56% of light comes inside, then we may say the VLT is 0.56. And apart from the mere property of the glass, we can also think about the addition of the shading device. Because when it comes to the glass, we won't generally keep it as such on the wall. Definitely we have to, if we give, definitely we have to give, but people are not giving it. They are going to mock the Western style mostly, even in our geographical location, but that's not a right practice. We have to provide enough shading whenever needed. Otherwise, the glass that we have to use will have to be more performing, like to buy that kind of high performance glasses. When you think about the total spending of your project, it will be considerably high. So why don't you think about creating an efficient shading device, and that will act an effective SGC to your building, okay, rather than considering the material SGC property. Your shading device also will help you in enhancing the SGC of your opening. Another fact is that the insulation, like, if either through this single assembly or through the combination, we can do that. And it provides better thermal comfort, and it also, creates a segregated environment in your space, especially if you are going to have an air-conditioned space. Then definitely the insulation is a factor, because to reduce the heat loss, and also it enhances acoustical performance and improves appearance, apart from whatever benefits we said. Okay. So this is a basic principle when we think about the energy efficiency factors, the strategies, the passive strategies that we were discussing. So let's come to the rating systems. Okay, so whatever things we have discussed, where as I said, there were passive strategies, and there were two more pillars. We are coming one by one. So before that, I will give you a glance through this rating systems. Because this all of you must have heard about LEED or BREEAM or all those kind of international names, right? So similar to that in India as well, there are a few green building assessment systems has been created. And first of all, let me tell you what are the purpose of this rating system. Okay, if we are performing better, like let's consider a few bunch of students in a classroom. Okay, all of them are learning. Let's say in one school, some people are studying under state syllabus, and in some school, people are studying under CBSE and ISC. Okay, so in all those classes, let's say 10th standard students, all of them are learning a set of programs, and they are writing examinations, and then we are comparing them based out of their final mark rate. There should be some kind of benchmark to evaluate and to understand the performance. So similar to that, you can design green buildings in n number of ways. But if you want to evaluate based on certain parameters, you may have to go through any of the systems. Because for all these systems, the underlying principles are based on sustainability, but the weightage that has been giving, or the context that they are taking, or the approach for this what you say, the complaints will change a little bit, but the principle behind all these systems remains same. So first one will be the Indian Green Building Council. The second one will be the Griha. Third one is GEM is a quite new system. And also the Bureau of Energy Efficiency has created building rating system. So let's see. And the first, the most important one and the mandatory one, the Energy Conservation Building Code, ECBC. So these are the various Indian evaluation green building or energy efficiency evaluation systems available in India. So let's talk about the Energy Conservation Building Code first, because this is mandatory. Okay, all of us should learn this, because this is mandatory in Kerala, and almost I think 19 states in India are already made it mandatory, and other states are also working on it. So definitely will make it. And this Energy Conservation Building Code has been developed by Bureau of Energy Efficiency by Government of India. And they have done extensive research starting from 2004. And the first Energy Conservation Building Code has been launched in 2007. And as a part of that, almost all states are made their own codes based on the local conditions and the climatic aspects. They they took the essence and they notified it into local systems. And now this code is mandatory, as I said. There will be 3 categories based on the new ECBC. As I said, the first ECBC was launched in 2007, but later in 2017, Bureau of Energy Efficiency notified the new code, so which is in practice now. So in the new code, there will be 3 levels of rating. The one rating will be the first minimum scale rating will be the ECBC certified. And if you perform a little more higher, you will get ECBC plus. If you perform the most efficient way, then you'll get super ECBC. So how do they evaluate and they will come up with ECBC plus, super and all? Because they have divided the building systems into 6 components. What are these components? First component is the building envelope. Second component will be heating, ventilation, and air conditioning. Third component is the day lighting and shading. Fourth component will be electrical power and motors. Fifth one will be the service hot water and pumping. And last but not the least is the renewable energy installation. And in the beginning, we have discussed about the energy consumption statistics of the building systems, right? So in that, we found that the most of the energy is getting consumed in commercial and other type of buildings rather than residential buildings. So keeping that in mind, Bureau of Energy Efficiency launched the CCBC just for non-residential building in the first, like in 2017. So under the code, this almost all categories comes in except this residential and industry, the process-oriented projects. So what are they like? What are coming under the ECBC? It can be hotels, hospitality building, it can be shopping complex, it can be healthcare buildings like hospitals, outpatients, inpatient, like dispensaries. And when it comes to educational, there can be schools, colleges, institutions, universities, irrespective of the scale, it caters a wide range of typology. And when it comes to the businesses, large office, medium office, small office, and SM, multiplex theaters, so almost all categories. Please don't mistake with the categories of KMBR, because if any civil engineers and architects are here, we will be, when we say commercial, group F and all that will be coming under our group G, right? Sorry, will be coming to our mind, but it's not that. The definition of commercial by ECBC is entirely different. It includes all building typologies except residential and industry. Okay, so and next, a little late, maybe by 2018, Bureau of Energy Efficiency has launched another code, particularly for the residential system, which is named as Econivas Samhita. So initially, we was concerned about the commercial energy consumption and made it voluntary in nature first. And at 2017, they made it, like in Kerala, actually, they made mandatory in 2020. So in presently, Econivas Samhita is also voluntary in nature, but we cannot predict, like it is a need of the heart. So definitely it can also be coming to practice as mandatory thing in near future. So considering the growth in the residential building stock, ministry has developed this, and the factors under this code is also the same principles that we were discussing. Okay, ECBC talks about heat gains or heat loss from the building envelope first. Okay, and then comes to the natural ventilation potential. Like what is the inlet sizing, outlet sizing, and what is the position of inlet and outlet, and is the openable window to floor area sufficient as per the National Building Code. So they are evaluating all these factors. And then it comes to the daylight potential. Daylight is talking in terms of useful daylight illuminance, because as I said, the space should not be underlit and should not be overlit. So ECBC says, like if we talk in terms of lux levels, it should be between 200 lux to 2000 lux. So anything above that is considered glare or the discomfort, and anything under 200 is also underlit. Okay. So when we come to the ECBC code, certain requirements are there kept as mandatory, and certain requirements are kept as prescriptive. Actually, there are two ways to prove the compliance through energy conservation building code. First is through writing, checking and writing prescriptions and calculating through manual means. And the second one is using advanced simulation methods. So it is our choice that we can take any of this method and we can prove compliance. And it talks about other systems like lighting and controls. And because in a case of not just natural lighting, artificial lighting is also a factor. We have to use it in deep core plants where daylight increase is less, and also on odd timings, maybe due to weather conditions or rainy seasons, we need artificial lighting for sure for buildings. So what we can, what are strategies can we do to reduce the consumption of this lighting? Maybe like the sensors, daylight sensors, or the occupancy control settings, or the based on the type of your building form, what is the shape of it and what is the the occupancy of it, and based on that we can work out on it. Another factor is that the equipments, electrical equipments that you are using. What are the motor in lift, or motor for water pumping, or motor for other uses? It should be based on the standards prescribed. At least it should be at least IE2 efficiency class as per the IS standards. And when it comes to the metering, it says to install digital meters. Okay, digital meters with the energy and also the power factor. The power factor has to be kept unity. In Kerala, it's following for almost our KCB or any other service provider is concerned about that and being followed. Highly recommended. And when it comes to the renewable energy, the code says you have to give 1% of the total peak demand or 25% of the roof area, whichever is convenient less. And in KMBR also there is another requirement, so we may have to match it for sure. And other efficiency parameters are there in terms of water heating or any other equipments, like may have to. So we can broadly say that the vision for ECBC, it is initially implemented for reducing energy, but now we have a new net zero goal for 2050. So definitely it will help, and it responds to the changes in the building technologies. Initially the code has notified in 2007, but again after considering the advanced systems, they enhanced the code in 2017. So similar to that, we will have to. And it also points out to the energy savings and without compromising to the comfort of the occupants. So both these indicators are two sides of a coin. So we cannot solve the problem without solving one. And as expanded coverage for more building, they are now notified for residential also. Only industry has to come next. And mandatory implementation is also getting enforced. So let's come to the next system, which is GRIHA. GRIHA means green rating for integrated habitat assessment. Sometimes as the name GRIHA means home, right? So thinking of that, many people have this misconception that GRIHA is something for residences. But not that. GRIHA is a rating system framework, green building framework developed by Terry. They consider and they enlist a wide typology of building. I list out, and the rating system has first come in 2007. And this particular rating system will rate a building based on stars. Okay, starting from 1 star to 5 star, based on the point that we give. And this particular rating system is developed by Terry, the Energy and Resources Institute. And this is also considered as a national rating system of India because of its contribution by Ministry of New and Renewable Energy, Government of India. And many government buildings are enforced to take this particular rating system. And Griha works on the principles like that what gets measured gets managed. And there are Griha variants, as you said, it cover homes, it cover offices, it covers schools, hospitals, apartments, institute, hotels, factories, whatever large developments, the shopping complex and airports. And in Griha, we can take a rating system based on the based on the area or the stretch of the building. If you are having a small building, like less than 2,500 meters square, then we can go for small versatile affordable Griha, SVA Griha category. Second one will be if your building is more than 2,500 meters square and more, you can go for a Griha, in general Griha. Okay, and it also comes up with the version, like presently Griha 2019 is running. So based on that, how many revisions they'll take, they'll add on the version name. And Griha LD is for large developments, which is more than 50 hectares. And Griha affordable housing is there. Houses maybe like that are under the PMAY scheme, or the affordable housing that is being settling by the governments and other trusts. You can go for the system. And for existing building, there is a separate system because evaluation for existing and new buildings are entirely different. We know the process, how it works. Okay, and for the existing day schools, another different, and cities. You have cities is new rating system. So we discussed this. And for the simple, versatile, affordable Griha level, there are only 50 points in total. As you said, all of the system has 100, but this particular one has only 50. Let's come to the next system, that is PEE star rating. This is actually in a baby stage. There are not much footprint of BE star rated building in India, though the building was set up in 2002, but it did not widely adopted. Like it is again also in 2018 also they revised it, they came up with more ratings and all, but still this is under process. And IGBC is the most established, like it started in 2001. That is the first implemented rating system in India, and which is developed by CIA Swaraj Gold Godrej Green Business Center, Hyderabad. And IGBC was actually a clear, essence of the USGBC in the earlier system. You must have heard about this Lead India in beginning, right? So it is the parent version of it. And then if you think about IGBC rating system, there are again, there are more and more and more category. If there is a typology, there is a category for IGBC. Unlike Griha, they are not rating in, they are taking the category in terms of the area. They are taking based on the type of building. So there is IGBC Green Home, Green Healthcare, Green Resort, Green Interior, Green Campus, Green Township, Green Landscape, Green CES, Green Railway Station, Green Metro Station, Green Existing Mass Rapid Station, and existing building has another one, Green School, Green Data Center, Green Affordable Housing, Green Residential Societies. So you may go to the IGBC website, you will find all this. Like they will definitely come up with another set of 5 rating systems in 1 year. That's my assumption. Okay, you can check clearly, update their go through their website and get updated. Okay. So IGBC Green New Building is also rating in terms of 100. Like if you having the most performing building is titled as platinum. For Griha, it's in star basis, but here they do it like silver, certified silver, gold, and platinum. The least performing is certified, and most performing will be platinum rated. And in IGBC, there will be 7 sections based on sustainable architecture and design, sustainable site selection and planning, water conservation, energy efficiency, building materials, resource efficiency, indoor environmental quality, innovation and development. So as the name says, the first, the profile is the sustainable architecture and design. So in this particular category, the contribution of architects will get evaluated mostly. So what are the architectural design principles that we approached, and how are we going to, allocate the spaces, and what is the concept of your facade, and what, all these factors will be evaluated. And site selection and planning will have site preservation, or what do you say, even in the stage of construction, they check for this site preservation parameters. And when it comes to the water conservation, the consumption, total water consumption, total pollutant water generation, and also total rainwater harvesting, and total harvesting by tank, and total recharge, rainwater recharge to the ground. So all these factors will be evaluated. And when it comes to the energy efficiency, there will be a base which is ECG. For both these systems, even if it is Griha or it is IGBC, the underlying document, which is, as a Bible they consider, is the ECBC. So definitely you have to be satisfied with ECBC for getting the mandatory clauses of Griha or IGBC cleared. And apart from that, if you are having further savings like 20%, you may get 1 point, 30%, you may get 5 points, like that. Similar to how much you save, you will get a point consecutively based on the amount of energy that you are saving. Similar to that, the amount of water you are getting saved, you will be assigned with the points. When it comes to the building material and resources, they will be checking what kind of material are you using, what is the this embodied energy of the material, and what is the thermal performance of the material, or where did you source the material, is that a local one or is that an exotic one, and what is the environmental impact that material causes. All these factors will be checked. And under the indoor environmental quality, most of the occupant comfort factors will be analyzed. The quality of daylight of the space, or the quality of the view that can be provided in each room, or the quality of acoustics, and the quality of thermal comfort environment that we provide. All these factors are analyzed under indoor environmental quality. And if you are having some kind of exemplary performance in any of the credits, like any of the site measurements, if you're coming up with some kind of exemplary performance, or in water conservation, you're coming with some exemplary strategy and you are saving hell lot of water, then definitely this innovation and development credit will take under that, and you'll get more points. So this is how the basic system of these all these rating systems work. And let's come to the simulation. Okay, so that is the last part of our presentation. So before that, I think you are clear about the approach of what is green buildings rating system and how do they do the rating. And if any of you are interested, we can have more sessions in each of the systems, and we can learn more for sure, because that itself in general, this Griha rating systems, in general we take classes for 3 days for teaching the entire things. And for IGBC as well, like more than that we may have to, because there are more rating systems. Okay, let's come to the simulation. So what you mean by simulation? What is simulation? Okay, we have heard the term, right? So simulation is more like a gaming. We heard about this flight simulation game, right? And this crash simulation. So it is the imitation of a situational process. And for this, we create the virtual models and we try to uh, give all the the scientific variables, and we try to forecast what shall be the performance in future. So this is more like when it comes to the building simulation, we should analyze over a period of time. We should analyze how our building is getting performed. Particularly, we know about the seasonal variations, right? So the summer seasons will have a different kind of heat inundation and the insulation levels compared to the rainy season. So in a rainy season, there can be a different kind of, the daylight ingress compared to the summer season. So all these things has to be forecasted clearly, right? Then only we'll be able to prove that the recommended level of daylight is getting on our work plane or on our surface, or considerable amount of heat gain can be reduced in summer particular daytime, right? So for that, we can have simulations for anything and everything in many applications related to the thermodynamics or related to the fluid dynamics, or any many applications are there. And let's talk about energy simulation, as we are concentrating today's session about energy conservation. So energy simulation, a computer-based program will be created with the help of any tools. There are any number of tools available. And after, similar to architects generally create a 3D model to understand how the appearance will be. Like we will not compromise about the aesthetics, right? So to understand what shall be the looks of the building, we create that particular architectural model. So similar to that, to understand the performance of the building, we will create the elements of the building, and we will assign the exact properties of that particular building, maybe especially the thermal properties of the building, and we will simulate with the help of the simulation tool. Actually, in energy conservation building code, we spoke about two approach, right? One is prescriptive one using prescriptions. The second one will be the approach using simulations. So that is termed as whole building performance method in ECBC. So in ECBC, they have clearly given what all assumptions has to be taken and analysis has to be done for which all periods, and what shall be the limits of results that we shall fall to understand that is better performing. So this is how it works. And on left hand side, you can see a simulation model and some kind of results. So when it comes to the building energy simulation, first of all, we have to mark the building design parameters. Okay, the design model that is created by the architect. Then we have to understand the outdoor environmental condition. Where is our building is located? What is the latitude and longitude? So we know that based on that, our sun path will be followed. And also the temperature and all the climatic factors will be there. So we have to map the outdoor environment in the simulation engine. So in general, we map this in terms of climatic weather data files. It is available. So we may find out the apt weather data file for our particular geographical location, and we can link that file to our simulation engine. Similar to that, we have to create a building model. We have to create the building based on the building design parameters, which is designed by the architect. We have to create the building model. Then maybe as per the mechanical MEP design, which is given by the HVAC consultant, we have to understand the HVAC system model or HVAC plan model. And then we can model the control systems. As we said, it can be in the HVAC, it can also be in the lighting. Okay, in lighting can also be controlled, and we can do that simulations as well. So as we are thinking about the thermal comfort and energy aspects mostly. So after this, everything has been mapped, then we will be able to simulate and get the indoor environmental condition. What shall be the temperature of your indoor, or what shall be the cooling load within your that particular environment, and what shall be the humidity, or what shall be the what do you want based on the inputs that you have given, you will get a output. And obviously the energy performance, what is the consumption in kilowatt, maybe annually or monthly, or based on that we will be able to assess. So this is how this entire procedure works. So as we said, as we understand in general, if we understand, okay, our building doesn't look good, then we'll definitely change the shading device or the color of the model, right? So similar to that, if we understand our energy performance is not up to the mark, then definitely we'll go back and we can do a different energy conservation measure. And we can change our building system, like walls or doors or window, or the entire shape of the building, or the type, like the zoning of the building, and everything together. And then we can come back to this energy performance analysis, and we can after doing a number of iterations, then we will come to the optimized model. That's how in general happens practice. So this is how we can understand how much energy is consumed. So this is actually my last slide. This is a factual figure which is also published by Bureau Energy. Let's see along, because we generally say this 65 million units of electricity can be saved through energy conservation strategies all over the country, which can supply electricity to 40,000 rural families. Okay, so I would like to conclude saying this: the cleanest and cheapest form of energy is energy conserved, not the energy generated using tidal power or hydropower or wind power or solar power or whatever. They are clean. In general, we term it as clean, but the most cleanest and cheapest is the energy that we conserve. Thank you, everyone. And I'm open for your questions. So please let me know if I want to explain something more further, or shall we go?
Thank you, Architect Ashiqua, for this very informative session. Is there anybody who would like to ask questions from the participants? Okay, so
move on to panel discussion, then we'll come back for this.
Okay. So let me now take this opportunity to introduce our panel members for today's knowledge sharing session. Firstly, Mrs. P.G.Girijadevi. She has done her master's degree in technology in construction and engineering and management. She's former superintendent engineer, LSGD, now working as a senior consultant in KMLR for Smart City Works. I now invite Mrs. P.G.Girijadevi to speak a few words.
Thank you. Can you hear me?
Yes.
Good evening to all. And I am appreciating so much to Dr. Mathew, the founder and trustee of Center for Environmental Efficiency, for endowing this platform on this important day. Dr. Mathew bring in detail how green building can conserve energy efficiently, how it is connected to environmental theory. Our architect Ashiqua Sulthana has presented in detail about green building concept and materials and technology used, how the goals can be achieved. She said there are 4 pillars for the development of energy efficient building. As we know, the 4 pillars are building envelope, comfort system and control, lighting control, and electrical and renewable system. She explained very well how it is optimized, how it is stimulated, what is U factor, and we got an idea about green building concept. Then I am adding some more points because I am working in smart city project. In smart city project, the strategy is developing smart city as a following green concept. When we are following green concept, we are going for the green building concept also. How to improve the green building, how to construct green building. So we got more information from this presentation. And then we are thinking about the earlier government building. When we are going to government building, they are maintaining the temperature below 20 degrees. But now government is taking more rules. They are implementing mandatory rules for maintaining the temperature in offices, government offices, from 24 to 25 degrees for airflow, for appropriate airflow or conserve energy. In KMBR or Kerala building rule also, up to 2012, there was no provision for energy efficiency and green building concepts. But in 2012 amendments, government has implemented some mandatory provisions like solar, assisted water heating, light system, groundwater recharge, and waste disposal. And another thing is in 2019 amendments, we can see the green building concept. So the citizens or people will get how optimize energy, how conserve natural resource, how generate less waste, and how we can get certificate of ECBC. Another important thing we can see in 2019 amendment is urban forestry rule. As per section 4 of Kerala Promotion of Tree Growth in Non-Forest Area Act 2005, every landowner, if he has more than 450 square meter of plot area, he has to plant a tree. That's a mandatory rule. Now the government is gradually enforcing the green building concept. And we can think if green building is expensive, actually the construction cost of green building is expensive. It is 5% higher than conventional forms. But when it covered 3 or 4 years, the maintenance cost is very less, and it is a guarantee, and it has more multiple returns of energy conservation. The angle of we are thinking about the angle of energy efficient building. The green building is more, it is not costly than conventional method. We can take Kochi Metro as a model because IGBC platinum rating in the Kochi Metro corporate office got IGBC certificate platinum rating by scoring 86 points out of 100. So can take as a role model for government building. When we are focused on government building, all metro stations also got green rated. They are using green rated materials for constructions. And they have followed energy efficiency performance index early. When we come to the taxation point, if in municipal corporation, they are assessing tax by dividing the area in the city into 3 zones. One is primary, secondary zone, and tertiary zone. We know the main public transport or metro are flying through primary zone. The citizens living around metro station are using this metro only. They obviously giving huge saving of energy, but government is imposing more tax for these citizens. So we have to address this type of anomalies. They are using public transport. They are producing less. They are not polluting our environment, but government is imposing more tax to this type of citizen. We can think about green stormwater infrastructure also. In Cochin city also, when small rain, it will be flooded. So we can think about small type of green stormwater infrastructure. Now corporation is taking some initiative to mitigate runoff by constructing this type of green stormwater infrastructure and green building. Main corporate office is going to construct as a green building. And I think my fellow panel members Shakeela and Krishnakumar sir can add more about green building. Thank you very much.
Thank you, ma'am. Next, I would like to introduce Mrs. Shakeela Moosa. She's a civil engineer with Masters in Industrial Engineering and Management, having 25 years of overall experience in developing and implementing sustainable strategies, which are both cost-effective and minimize long-term environmental liabilities. I now invite Mrs. Shakeela Moosa to speak a few words.
Can you hear me?
Clear.
Okay.
Yes.
Good evening once again, all of you. Dr. May, thank you for the invite to this webinar, and very, very interesting. I know Dr. May since 1979-80. In fact, I am a witness to her academic brilliance and her no-nonsense approach to life and issues. 40 years down the lane, I am happy to note that she is passionate about environmental efficiency and striving hard to implement the environmental efficiency theories she has developed to make Earth sustainable, Kerala in particular. Though I have not lived in Kerala for the past 3 decades, Kerala is in my heart and thoughts always. How can we forget? What a place. Correct? Mountains on one side, oceans on the other, 44 major rivers running in and out. Top of it, 100% literate population. But sad to hear that, or read rather, and see in TV that we have destroyed our forest, polluted our rivers and blocked our rivers and water bodies, converted our agricultural land and other water bodies to construction sites or waste landfills. And what is the result? Now we hear about recurring floods, landslides, and climate change or unusual rains, unusual warm weather. Climate change is for real, I feel. And I believe it may be mostly due to our ignorance or our lack of commitment to save Kerala or the earth or the environment for our future generation. But I am happy to note that from Ashiqa's and from Girija's presentations or talk that we are moving in the right directions. At least now we should act. In UAE, which is home for me for the last 25 years, I am fortunate to lead a team of passionate green professionals, green building professionals. We call ourselves Sustanomics, meaning sustainable development most economically. At the end of the day, economy is the bottom line. If the economy is not sustainable, there is no development. There is no sustainability. What do we do in Sustanomics? We assist the architects, the contractors, the clients, or the end users to find and implement sustainable solutions in their built environment or in the buildings they are building. We do this end to end, from design to construction to operations to maintenance to use of the building. And we act as their trusted advisors to make the right choices within the financial constraints or trade-offs. And the guidelines we specializes in UAE are LEED, BRIAM, or GSAS in Qatar, Estidama, Al Safat in Dubai municipality, EHS Truckies regulations, and DSOA regulations. These are all green building regulations for different organizations or different agencies. But the underlying principles and intentions are the same. The quality of indoor and outdoor environment is considered and protected throughout the design, construction, operation, maintenance, and use of the buildings. It is an attempt to balance economic, social, and environmental factors. We cannot separate these factors. Environment cannot be independent of social issues, and it cannot be independent of economical issues. And what do we achieve? Optimize energy consumption, improved energy efficiency, increased water savings, reduced pollution, enhanced indoor air quality, hence better productivity, and reduced operational cost. Since I am living in UAE for the past 25 years, I can talk more about the environmental issues or environmental causes in UAE. In UAE, what I see most encouraging is its rulers' vision and commitment to environmental causes. In 2007, His Highness Sheikh Mohammed Rashid Al Maktoum, ruler of Dubai, issued a resolution or directive that from 2008 January onwards, all owners of commercial or residential buildings must comply with the internationally accepted green building regulations or specifications for all the constructions to make Dubai a green Dubai. This requirement became mandatory in Dubai, and the authorities or the agencies like municipalities, special zones, establish the green building regulations in their jurisdiction because they are responsible for the regulation of the built environment in UAE. It became mandatory, meaning if you do not comply the green building concepts into the design and construction of the building, you do not get the building permit or you do not get the building completion certificate. That's it. Your finance is stuck with the building. So it is followed religiously in Dubai, and most of the agencies, most of the organization made it mandatory for a third-party green building consultant like Sosnomics to certify that design is as per the green building regulations and follow through the construction to make sure and certify that the construction is done as per the green building design. Another amazing thing in UAE I noticed is that their awareness campaigns by the government and by the media, awareness campaigns, they educate all stakeholders, trying to educate all the stakeholders, from children to adults, from Emiratis to expats to visitors, from workers to engineers to consultants to bureaucrats to clients. They are trying to make all of them aware of the environmental issues and the impact of our actions on the environment. It's amazing what they do. I can give you a small example. Recently, 2 days ago, on the 12th of December, there was an article in a leading newspaper daily in UAE. Dubai government goes paperless. Dubai government saves 336 million papers by their paperless strategy. Dubai government saves 1.36 billion dirhams from their paperless strategy. This is in the paper. I read it as an entrepreneur. I think, oh my God, what can I save? If my organizations go paperless, how many trees I can save if I go paperless? It's an awareness canvas. It did not happen just like this. In 2000, 4 years ago, the ruler announced his vision that from 2021, no Dubai government employee or customer need to print any transaction or everything digital. And they saved 336 million papers. So this is amazing. Like on the same day, again, I remember on the same day, there was another article on the same newspaper saying that Dubai's Emirates environmental group cleanup volunteers collected 13.6 tons of waste from Al Qudra, Dubai. Al Qudra is a man-made reservoir which has become a very important sanctuary for the migrating birds, animals, reptiles, insects, etc. Interesting news piece, which will encourage, which will educate the common man who is reading the newspaper, or the children, or the professionals, make aware of the environmental impact our actions have. Amazing. So I cannot conclude this without telling about other initiatives like Sustainable City. There is a city called Sustainable City in Dubai. It is net zero. It is a net zero zone. Net zero. I mean, Ashiqua talked about net zero. It's a net zero zone. That means there are about 500 villas, which is totally green. Totally, the carbon emission from it and the carbon emission saved is, the net is zero. There is no environment impact because of these villas to the environment. It has more than 2,000 trees in that environment. It has 11 biodomes of about 3,000 square meters of cultivation, where the residents can go and grow their own vegetables and fruits. Amazing. You know, slowly, I mean, every day, day in and day out, we can read about environmental issues and environmental remedial measures UAE is taking. On 18th of October 2021, the rulers of UAE announced their net zero to 2050 strategy. It is going to be the first nation to achieve in MENA region. UAE will build the first net zero nation in MENA region. I hope, and from Ashiqa's and Girija's presentation, I understand that Kerala and India are also on the same path of achieving net zero 2050 in 2050. And I hope and pray that we all stand by India and Kerala to achieve that. Thank you.
Thank you, ma'am. Next, I would like to introduce P. Krishnakumar, who graduated in Mechanical Engineering from Government Engineering College, Thrissur in 1983. He joined FACT as a management trainee in the same year and worked in FACT Engineering Works, the Fabrication and Construction Division, and FACT Engineering and Design Organization, or FEDO, the Design and Consultancy Division of FACT, in various capacities. He left the services of FACT in 2004 while functioning as the Deputy Chief Engineer in FEDO. Later, he worked for international companies like Gretco Ansari in Bahrain and Tebodin and Partner in Muscat, before moving to W.S. Atkins and Partners Overseas, Sharjah. He is a life fellow of the Institution of Engineers in India and is actively associated with the activities of Thrissur Local Center. He was a former honorary secretary of the Thrissur Local Center. He is also actively involved in various social activities in Thrissur and contributes articles to newspapers and other publications on issues related to transportation. I now invite P. Krishnakumar sir to speak a few words.
Thank you, Megha, for the nice introduction. Good evening to all of you. First of all, let me congratulate Center for Environmental Efficiency, especially its founder, Trustee Dr. Mathew, for organizing this wonderful event to mark the National Energy Conservation Day 2021. She has been instrumental in bringing out the concepts of environmental efficiency and carrying capacity into the arena of sustainable development. Her continuing efforts to propagate these novel and powerful concepts among the stakeholders is really commendable, and my appreciations to her and the whole team. Today, she has elaborated on green buildings, how green buildings can contribute to energy efficiency without compromising much on human comfort and convenience. Ashiqua Sulthana has talked about in detail about Indian energy scenario, roles played by the central and state governments, etc., in the energy conservation and in green buildings. Shakeela has also explained about the green building scenario in the UAE and the various steps the governments in UAE are taking for a sustainable world. Engineer Girijadevi has also discussed about the rules presently and the scenario in Kerala, and she has discussed about the tax concessions offered to green buildings in Kerala. She has suggested tax holidays or tax concessions for green buildings to popularize the concept. Environmental efficiency, according to me, is the apex umbrella for sustainable development, covering all aspects of sustainable living and development. Let us take the example of transport sector. The move to just shift to electricity and hydrogen as energy sources for transport from fossil fuels may look like efficient in the prima facie, but shifting our dependency to public transport using electricity and hydrogen as fuels is much more efficient in environmental terms than just changing the energy source. Along with changing to non-polluting energy sources, we should move to public transport also to become more environmental efficient. Actually, just by shifting the energy source of private vehicles more to non-polluting sources alone will not meet the requirement of an environmental efficiency. From an environmental efficiency angle, we should promote public transport also along with this present change. Then only it will become more efficient. I would also like to add that energy efficient auditing should be made compulsory even for residential buildings in Kerala, as the major share of electricity consumption of our state is from domestic sector. Renewable energy should be made compulsory in isolated and scattered settlements in rural Kerala, where the distribution losses are more due to tree touchings, etc. For making the common people aware, first and foremost thing to do is to make all people understand that energy conservation is much beyond just electricity conservation. In a state like Kerala, where as per the latest census reports, more than 60% of the people still depend on firewood for cooking, where almost all basic food materials are transported for an average of 1,000 kilometers or more from neighboring states, where building independent bungalows have become the status symbol, where more than 1 million houses are just built just for keeping it closed without anyone residing in it, where land has become the most scarce resource, where the waste management has become a perennial problem, where water is going to be a scarce resource in spite of having 44 rivers. The concept of energy and environmental conservation, sustainable development, and social responsibility has to be drilled down deep into the minds of the society and our people. I think such sessions which Center for Environmental Efficiency is conducting will go a long way in doing this aspect. Thank you. Thank you for giving this opportunity.
Megha?
Thank you, sir. I would now finally like to invite urban planner, Mr. Biju Narayan, to speak a few words.
Just to make his presence, because he told me that he will be speaking next session.
Okay, fine.
You just come on video, so that we want to acknowledge the services, voluntary services done by you, that is in managing this event from a remote place, sitting in his house.
Yeah, it's okay, ma'am.
Yeah.
It's very nice
He
to.
is an urban planner from School of
Yes.
Planning and Architecture, Vijayawada. And he is
Yes.
tirelessly working to achieve his goals, because urban planning means it is nothing but sustainable development.
Yes.
Okay, thank you, Biju, for this
Thank you, ma'am.
management and the voluntary service. And I look forward to more and more volunteers like this, and you also to come and attend these kind of sessions, so that we can jointly move forward towards a sustainable Kerala and sustainable India and sustainable world.
Thank you, ma'am. Thank you very much.
Okay, we will now proceed with the open discussion.
Anybody has got any doubts, they can ask. I think we are running out time, the committed time, so that if you have somebody, at least I think 4-5 minutes are there, you can just post your doubts. And even if we don't have time to address those questions, you just email to environmentalefficiency@gmail.com, so that I will refer it to Ashiqua, or if myself has to answer it, I will answer it. And if you want to know more about environmental efficiency theory, you can log on to www.centerforenvironmentalefficiency.org. And also with respect to Ashiqua, can you just refer some material, that means a comprehensive reading material with respect to what all things you have presented, a comprehensive, because instead of going through so many books and readings, is there any comprehensive book which explains all these things, so that the person who is interested in the screen buildings and all, they can start making an attempt to read about it? Ashiqua?
Sure, ma'am. Actually, we cannot simply say a single material, but still, I will recommend all of them to read the user manuals of different rating systems, so that they can compare themselves and understand the way of evaluation in different types of systems. And more than that, all of them should read the energy conservation building code, because it's anyway being made mandatory. And the underlying principles of energy efficiency has been clearly written, and there is a user manual is also published by Bureau of Energy Efficiency, and you can download both of these materials from Bureau of Energy Efficiency website for free of cost. And if any of you are interested in further learning, this Griha and all are conducting their own workshops, you may contact. And otherwise, many other consultants, even in our firm, we are also conducting workshops, awareness workshops, and also some technical enhanced programs. And if some of you are interested in software simulations, we are also engaging in those kind of activities. And Government of Kerala is also conducting a few software training workshops funded by government. So you may access all these things right now. Everything is available online. So you may follow the LinkedIn pages and Facebook pages of all these institutions. Then you may get the updates in time. And other than that, if as in books, I'll recommend Griha IGBC manuals and Energy Conservation Building Code 2017, plus its user manual. Thank you.
If you provide this PDF of all those things which you have presented, no, it would be nice for the enthusiasts to know about it.
Yeah, sure,
fabric,
I can.
Basic fabric, they will get a catch of it, so that they can develop it further. Because we want to inculcate a kind of energy efficiency, that means a culture in our society, so that the people who have attended it, they can have a reference material just containing the salient points, so that they can develop it further.
Yeah, sure,
So
ma'am. Sure, I'll provide the hand.
Those who have attended, once Ashiqua gives me the PDF, I will send it to you, so that you will
I have a question. If there is a time, I have a question to Ashiqua.
Yes, ma'am.
Where
Please.
where do we get the information about how many buildings are rated? I mean, I understand that all the commercial buildings have to be green rated in Kerala. Where do we get this information, and what kind of ratings they have got? Uh,
Actually, you will get this information if the project is being funded by the KIFBI, the information will be with them. And otherwise, you may have to approach the corresponding departments. Like if it's under the PWD, it will be under PWD.
So
there is no singular,
information.
even no singular information, because I was a part of this project which is funded by BE in 2018. So at that time we wanted this consolidated list and we couldn't get it. So finally what we did was we approached these rating bodies and collected a list from them, and we tried to consolidate. But with them as well, they don't have a complete set of completed projects, running projects, registered projects like that. They don't have the complete status. They just have a registered project.
That is the lack of data, and we do not know whether all are rated as they say. You said in your presentation that the conservation is the easiest, the cleanest energy
yes
created. So we
that's based on the
we do not have any source to make sure that we are doing that, or to know for the common man to know to get that information.
I think it is in IGBC. You can go through IGBC rating in their site. Maybe
in their website they will publish an yearly report. Yes, ma'am.
But in Kerala government has, Kerala government has no data regarding we had constructed 1,000 buildings or completed 1,000 buildings in this year, and all were rated C or B or super or ECBC.
Shakeela, I feel that we are still in the infancy stage because we only started. But I feel in the info park, most of the buildings are either platinum rated, gold rated, or silver rated.
Lead platinum.
Yes. So Ashiqua will be knowing about it
yes, ma'am. Lead platinum rated building.
That's how I heard first in Kochi. This green building from the that is what is it called, info park.
In Trivandrum also,
and also now in residential sector, many of the real estate companies like SFS, then John Thomas thing.
If there is a value addition in terms of commercial value addition to the buildings which are green rated in Kerala, people are aware and they prefer green rated buildings. Is there any trend like that?
Yes, now people are preferring this type of big art construction. They have provided more greenery, indoor and outdoor greenery. People are preferring that type of construction. Construction, they are also.
Ashiqua, can you give some idea how much expensive it would be compared to the traditional construction? If I am going for a platinum rated building and versus vis-a-vis a traditional building, how much percentage will be the elevation, post elevation? I would like to know.
It will again be depending upon the rating system that we generally take.
I'm just telling
you
about
go for
IGBC,
Indian Green Building Council rating system. Then if we are trying to achieve platinum through most energy efficiency and water efficiency clauses, then it may add about 10% for sure. Even more than that.
5 to 10
for IGBC.
That's all?
That's all.
SFS, now Skyline Foundations, they were doing some construction there in Kotte, the green rated. And
yes, I saw about the project.
Yeah, I asked him about the cost elevation. He was telling that it is 30% more.
No.
It will be depending upon how much they are going for. If they go for an exemplary thing with more automized and more technologies involved in it, because there are more credits. Like there are a few credits which just need the careful approach on construction and in site preservation and all. But in many cases, people will be denying that and will be going for advanced systems. So in that case, purchasing those systems, as I said in the case of smart glass, so then the cost will get elevated. So what I was saying is the underlying, like the bare minimum cost. And more than that, anything you can go for based on the technology that you are choosing and the based on the weightage of material that you go for.
Also, I feel that it makes a difference if all the stakeholders are involved from the beginning, like designers, green building consultants, contractors, and clients together. If we design from the beginning for a green building, I mean, high rating, the expenses may be not so prohibitive. But we try to make changes in between after making the design. I feel then,
Exactly, ma'am. Exactly. The alterations and the cross decisions will be so.
And compared to the best design, that's as far as the energy efficiency is concerned. That means IGBC, something like what is it called, IGBC? No, IGBC itself, ECBC super. Suppose I am going for an ECBC super and compared to traditional building, what is the break-even period? Suppose I am constructing and spending extra money, and then how many years it will take to?
Yes, will be like at least 5 years. This also has been studied. Like, it will take about at least 5 years. Yes.
Oh, that is green buildings are always good. Only thing is that awareness is to be created, and Center for Environmental Agency is trying to create an awareness on this topic so that more and more youngsters should get into this green building consultancy and knowledge and all, and also implementation, their own building. Okay, I think
we may be able to do some kind of survey or data collection as a part of Center for Energy Efficiency, because these kind of data are kind of missing, right? So at least we can join with a consultant and collect individual data from them.
And collect district-based data. That's also
Okay, thank you. So now I invite Mathew Jose, who is a fourth-year computer science student from National Institute of Technology, Calicut, and a CEE volunteer as well, to cast the vote of thanks on behalf of CEE.
Thank you. So firstly, I would like to appreciate the efforts of Dr. May Mathew and Anthony Katikaran for conducting such a webinar on national energy conservation and trying to spread awareness to our youngsters today. I'd like to thank architect Ashiqua Sulthana for telling us more about green building concept and trying to tell us more about what it essentially is and to guide us in that. And I would like to thank our panel members, that includes Girija ma'am, Shakeela ma'am, and Krishnakumar sir, for giving us your insights into this particular topic. I would also like to thank Biju Narayanan for ensuring the smooth flow of events and trying to conduct these events without causing any hassle to anyone. I would like to thank CE volunteers, includes myself, architect Megha Mibu, and architect Anna Cyriac, for trying to make the session more interactive and so that everyone is able to give their perspectives into this event. And lastly, I would like to thank everyone who was who attended this event. Like, it was able to start on time, end on time, and for sharing your insights, and we were able to learn together. I think everyone who attended here, everyone was able to learn something. And I think that is very good for this event. So yeah, that's it. Thank you.
I would like to some of the participants, some special participants like Dr. Sarah Ilarian. She is from Egypt. She has joined in our session. And Shankararan sir, he was the top person in the FSCT, and he has also joined. And Dr. Ravi, who used to be my classmate in SP Delhi, and he has joined from Vijayawada. And also my relatives, my friends, my family members, and also CE well-wishers, and also CE enthusiasts, and also the people from GCDA, and many people have joined me. It really encourages me. So that means they have joined this session. That means I feel like conducting more and more of more sessions like this. I'm really thankful to all people who have attended this session, because without the attendees, this webinar will not be a webinar. So that I'm really thankful to you, and I look forward to meet you in further future session. Thank you so much.
Thank you.
We'll call it a day.
Thank you, ma'am.